Talismania Deluxe is a game developed by the same team that created Plants vs. Zombies, but instead of zombies trying to eat your brain, you must solve small puzzles. You may be familiar with the concept of line puzzles, where you must draw a line while visiting every cell on the board. Talismania Deluxe is very similar in that it has cells, which I would call runes, a start and an end. However, your goal is not to draw a line through all those cells, as that is often not possible, but rather draw a line that connects as many cells as possible. And you are not supposed to draw a path yourself, but use existing pipes and rotate the hexagons to connect them together. When successfully connecting the start to the end, the runes light up and get turned into either gold, silver or bronze coins that are then collected on a scale. The goal in each level is to collect a certain number of coins of any type to fill up the scale. Now, as you might see, I'm not really good at the game, but I am good at programming a bot that can play the game for me. Before I can start, I need to set up the dev environment. I will be using Python along with PyAutoGUI for simulating mouse clicks and OpenCV for image recognition. After creating a function that will open the game window when I run the Python script, the first step will be to set up a state system which regularly takes a screenshot of the window, allowing me to do all kinds of AI image recognition magic stuff. Because I am insane and have too much free time, my goal is to automate the entire game from start to finish. That includes opening it, creating a new user, and clicking the start button. So I implement this in the script as separate states. To figure out what state the game is currently in, I let the bot detect when certain images are visible in the game. Those include the enter your name state, main screen state, press escape to skip state, OK buttons, continue game buttons, and the pause menu. Whenever any of those images appear in the game, I simply tell the bot to click at a certain position, most often a button, which will exit the current state and move on to the next state. After starting the first level, I need a way to tell the bot that the first level started. For that, I will simply use the left side of the level layout as an indicator that we are in the game and should be playing now. Now to the most difficult part of automating the game. I will need to tell the bot where the runes are, what type of runes there are, and in what directions the pipes point. I can think of a few ways to solve this problem, but the best way in my opinion would be to hardcode the positions of runes and extract the image for each rune from the original screenshot. After that, the first job will be to detect the type of rune. I did that in multiple steps. The first step is looking at the background color. I created a mask which I can multiply to the original image to only focus on the background of the rune. I then calculate the average color of the background and compare it to the average color of each rune type in the game. There are 7 different colors, including grey and blue for standard runes, purple and green for runes with special effects, which I will talk about later, and bronze, silver and gold for the 3 types of start runes. I took a screenshot of one of each colored rune. I also modified the images to remove pipes, which will be important for a later step. Now that I know what type of rune I am dealing with, I can implement algorithms for each rune type that can detect the directions the pipes point to. As you can see, there are 6 possible directions for the pipes, and rotating the rune makes the pipes rotate counterclockwise. For the default blue runes, my idea was to create a mask for only the areas where pipes can be, so I can again calculate the average color for each pipe area and compare it to the background color of the rune. If the colors match, or at least are very similar, I know that there's no pipe in that direction. If the distance between the 2 colors is bigger than a hard-coded threshold, I know that there is a pipe in that direction. For the start runes, that method would not work as the rune has almost the same color everywhere. As start runes only have 1 pipe, I first tried using OpenCV template matching to check each of the 6 rune rotations for a match against a known rotation. That way, whenever the matching score of the algorithm is above the threshold, I would know what the rotation must be by subtracting the number of rotations I had to do for the best score. Sadly, that approach had multiple problems. First of all, rotating an image by an angle that is not a multiple of 90 degrees is hard and screws with pixel colors, distances and stuff like that, meaning that the template matching, which would just calculate the difference between the colors for each pixel, would not work as well, as the rotated image would be skewed and misaligned. And second, the template matching does not work well for round images because there is a large black area in each corner of the circle. I quickly scrapped that idea and had to think of something else. To get some inspiration, I went to ask the World Wide Web and looked for ways to detect how much an image is rotated compared to another image. That is when I found polar image transformation. Polar image transformation is a method that is used to convert a round image to a rectangular one by projecting the coordinates of a circle to those of a rectangle. Having a rectangle means I can use template matching to my heart's content. I removed the problem of having a large black area, so the template matching capabilities should improve a lot. And they did. Seeing this algorithm work, I refactored my code, fixed a lot of bugs, and started working on a debug window to show me the rune's positions, rotations, types, and pipes. The only thing left was to include the border pipes, which was not hard because they would be the same throughout the layout. Now that I am 3 days in, having spent 10 hours on creating the rune detection, it is time to finally implement the solving algorithm. For the algorithm, I created an array of runes which starts at the top left rune with index 0 and then goes down and then to the right. It might seem weird to add the top left corner of the layout as a rune, but trust me, it makes the algorithm so much easier. Although I know for each index what type of rune there is and which directions the pipes point to, I have no way of telling if two runes are connected. Yet, to solve that problem, I implemented a lookup table where I entered for each rune, for each of its pipes, which rune that pipe would connect to, if any. After now being able to tell which runes connect to where with what pipe, I can work on figuring out how often I must rotate each rune to connect two start runes with as many runes in between as possible. Instead of trying out every combination, I can reduce the number of possibilities by not checking combinations that aren't relevant anyways. A depth-first search means that I start at the start, obviously. I then choose one rotation of the start rune and get the index of the rune it connects or could connect to. I then rotate the rune so that at least one pipe connects the two runes and continue the process for the next rune. If the pipe I am checking points to a rune I have already visited or there are no more pipes going out of the rune, the path is complete and there are two possible scenarios. 1. I ended in a normal rune. 2. The scenario I prefer, I ended in another start rune, therefore connecting the two start runes together. I continue that method until all pipes and rotations are checked. By keeping track of which runes have been visited for each path, I can calculate a score for that path if and only if it ends in a start rune. So it was simply a task of telling the bot to click on each rune, the number of times calculated. While my code still had a lot of bugs and problems at this stage, I was able to use it to play through some of the easier levels of the game quickly. So here's some of that juicy gameplay you waited for. Now I could say that I am done with this project and that's all there is to it, but that wouldn't be satisfying at all. The next steps are to implement the minigames that are part of each stage, more runes and fix a lot of bugs. And make everything even faster.
Venga.